Hi guys, a very good morning. This is Dr. Sajja Suneel from Data Science Department. Today, I'm going to discuss with you about IoT network and management system. And this class was a revision for this particular topic called IoT network and management system, which is existed in Principles of Internet of Course. And this session was divided into two parts, part 1 and part 2, which is related to the revision on multiple topics which I am going to discuss in IoT network and IoT network management. Have a look guys, what are the topics which are existed in this IoT network and management. In this IoT and M2M, IoT stands for Internet of Things and M2M stands for machine to machine, right? And these are the things which are going to be discussed in IoT network and management. In this thing, we need to focus on two major things which are very important one, which is SDN and NFV. SDN stands for Software Defined Network and NFV stands for Network Function Virtualization. These two are the major important topics in this particular thing, module 2, which is IoT networks and management guys. In this IoT and machine to machine, SDNs and NFVs are playing a major role. Along with these two, I am going to discuss about the differences between this SDN and NFV also, which are there in our IoT industry. And in my next class, which is a continuation for this revision, where we are going to discuss about the basics of IoT system and also the management of Netcom, ANG, NetOP, SNMP. These are the things which I am going to discuss in the next thing. And before starting discussing about these projects, why this particular module has been designed like this, once have a look. The major objective of designing this concern module in this way, because you guys need to know what kind of networks are going to support in this particular thing, how network on and yang are going to support, and how the things are going to be utilized in this network management and system. Along with this, you are going to ensure how reliably and the factors are going to be in this concerned thing. Those are the things which I am going to let you know, and how the connectivity will be. And also you guys are knowing how secure communication and how efficient data management will be done. And also how the device performance and the network management is going to be taken care. In this particular topic discussions, we will aim for these objectives and the outcomes which we are going to achieve after completion of this particular topic discussion was, you guys are able to know how operational efficiency is going to be improved, and you guys are able to enhance the security, scalability and growth of IoT systems, and you guys are able to reduce the downtime and improve the customer's experience. These are the things which we aimed for. Coming to IoT and M2M. IoT, Internet of Things, where multiple things are connected with a internet, and M2M, machine to machine, which refers the networking of machine or the devices for the purpose of remote monitoring and controlling and exchanging the data for a specific cause. And this can be shown to you in a small diagram. Once have a look. This is M2M area network, which is connected with a gateway to the M2M core network. Core network is nothing but a wire network. There is a combination of three different wire networks which are M2M core network. Area network. Area was different, core was different. And this network is connected to you machine to machine applications. How networks are, wire networks are, signal systems. And how this gateway is connected to area networks. Every area is having a wireless network which is connected to server. Got it guys? This is how the networks are being monitored. And with the help of this machine to machine gateway only, these things are going to be done. Have a look. A clear picture about this machine to machine service is going to be shown to you. First, With the help of our IoT, there was an accident which has happened in highway. Now it sends an alert which is generated after crash. That signal will be transferred to the remote servers, and these servers are going to transfer and redirect the signal to the nearest hospital, and also to the doctors, and also to the ambulance which are nearest. And these services are going to be utilized by the concerned car incident, where this ambulance is going to that particular spot and pick the person towards the hospital, and doctors are going to attempt it, and the paramedic team is going to be alerted, where these doctors are going to suggest the paramedic team to give the concerned medicines which are prescribed, and he is going to issue the medicines to the concerned person, so that the issue is going to be resolved in a smooth way in a crucial environment. This is how the things are going to be happen at the time of machine to machine. And now I want to differentiate what this machine to machine and IoT was before going into SDN and NFV. I'll start discussing with M2M and IoT. Here M2M, I already told you the observation is machine to machine. IoT, Internet of Things, and it is a direct machine to machine communication process. And coming to IoT, it is a sensor automation and internet platform. Here, the communication will be point to point, and here it is going to support cloud-based communication. And here, no device is necessary to rely on internet, but here the device is necessary to be on internet. And here we are mostly based on hardware, and here we are mostly based on both hardware and software. Here the machines are going to communicate with a single machine at a particular time, but here the user can access at any time over the internet. And here it is going to be non-IP based protocols. Here we are using IP based protocols, and here it is used for business to business type, and here we can use for business to business as well as business to customer type also. And here we are only having a limited number of devices, whereas in IoT we are having more number of devices which are connected at a specific point of time. And here we are supporting only a open APIs, and it is sorry, machine to machine it doesn't support actually. In IoT it will support. And coming to machine to machine, it is less scalable, whereas in IoT it is more scalable. These are the things which has to be considered, guys. And M2M, machine to machine gateway. Here in non-IP based protocols which are used within M2M area networks, where M2M nodes within one network which are going to communicate with nodes in an external network. To enable this communication between remote M2M area networks and M2M globals, here the M2M area networks are Bluetooth, Zigbee, Wi-Fi, LoWPAN, M-Bus, UB, Modbus, JetBus. All these comes under area networks. With this node, I am going to communicate with the gateway, where the gateway is having virtual node with native protocol, protocol translation, proxy. And these gateways are going to route towards the database. This is how M2M gateway is going to be utilized. And what are the different types of communications which are existed in IoT and which are existed in machine to machine? The above diagram shows you IoT, and here this one shows you machine to machine. If you observe first IoT, in this we are having four different layers: application layer, transport layer, and same in the right side also, both client server, right? And coming to network and link layer, those are to be taken care by M2M. There are four layers which I already told you in our discussion at the time of which is introduction to Internet of Things. There we have seen four levels: application, transport, network, link. Whereas application and transport comes under IoT, and network and link layer comes under machine to machine, which is a point to point communication channels. And have a look, in application layer we are having all the protocols: HTTP hypertext transfer protocol, constant application protocol, WebSockets, message queue telemetry transport, extendable message message protocol, and DDS, and also AMQP, advanced message queuing protocol, and transport layer, which is a combination of transport congestion protocol and UDP, user datagram protocol. Like this, multiple protocols are there. And coming to network layer, IP version 4, IP version 6, and 6 low power WAN. And coming to the link layer, Ethernet, Wi-Fi Max, cellular networks, Wi-Fi, wireless PAN. These are the different kinds of link layers which are established at both client and server. Client and server. This is how the communication is going to happen in IoT and machine to machine. This is the inner diagram which is showing a current overview of current network where user 1 and user 2 are going to communicate it. Whenever a switch is attacked, automatically the switch is going to divert the things, needs to reroute with an alternate path. Whenever a switch is attacked, we need to reroute the things to transmit the data. That is how the things are. What are the limitations for this particular current network? Here, the vendor-specific architecture of switches limits dynamic configuration according to the application-specific requirements. Here, whatever the switches we are using, we need to configure according to the installed operating system. And if there is a centralized control, which is not feasible in traditional network. And there are thousands of lines of code, which is going to be routed to the mobility of certain apps, and which is cost expensive in operating system. And also there are millions of gateways which are going to show the special packet for showing towards the hardware system. And this is how the current network to SDN, software defined network, was. These are the things which are existed in SDN, how the network is going to be. Between an operating system will be there, which is going to be interlinked with the application which we are utilizing, and the packet of forwarding hardware and packet of information is going to be taken through that particular operating system through the concern. Yeah, that is how the things are going to be communicated through a network. And this was the diagrammatic representation for SDN architecture. Once have a look how the SDN architecture was. In this SDN architecture, we are showing with multiple things. There is a well-defined APIs, which are security, routing, traffic engineering, and other application. All this comes under network virtualization, function virtualization, NFVs, network function virtualization. And there is application plane as well as control plane. Application plane which takes care of NFCs, and control plane which is going to take care of separation of the data by using these particular things. In this northbound API and southbound API depends on the open flow. Northbound API application programmable interface and southbound application programmable interface. In between, network operating system will be there where it is shows a map abstraction, and in control panel we are having multiple things which are shown to you on screen where we are formatting the data by utilizing the NFC structure. Whenever if there is a congestion happening in some network, automatically the traffic engineering has to be reroute the things. This is how the data plane function is going to function. And this is the SDN network, as the software defined network. In this software defined network, as I told you, application layer and infrastructure layer. Application layer consists of different kinds of network applications which are existed in it, which is coming to northbound layer, where in network operating systems which are in control layer, and coming to the southbound layer, which is infrastructure layer, where simple packet of hardware information is going to be rotated in southbound layer. Whereas in northbound layer, different kinds of network application will be presented. Whereas in control layer, only network operating system is going to be considered. This is how the SDN structure is going to be defined. As I told you, it is a networking architecture which is going to separate the control plane from the data plane and centralize the network controller. These are the three key elements which are presented in SDN. The first one is centralized network controller. The second one is programmable open APIs. And the third one is standard communication interface. Coming to centralized network controller, with a decoupled controller and data planes and centralized network controllers, the network administrator can rapidly configure the network. Whereas programmed open application program interface, here the SDN architecture is going to support programmable open APIs for interfacing between SDN application and control layers, which are northbound interfaces. And coming to standard communication interface, which is a open flow where SDN architecture is going to use standard communication interface between the control and infrastructure layers, which is southbound. Northbound means the control layers where open API interface is going to be presented between SDI application and control layers. Whereas in southbound, which comes under open flow, where the interaction between the control and infrastructure layers. This is what the difference between the things are. The major key elements such as centralized network controller, programmable open APIs, and standard communication interface, which is open flow. These are the key elements which are presented in software defined network, guys. And coming to the next thing, what are the key elements which are presented in SDN? I already told you three major things, which is centralized network controller, standardized communication, and programmable open APIs. These are the key elements which are considered. And along with this, open flow, open networking foundation is the broadly accepted SDN protocol which comes under southbound interface. And coming to NFV, which is a technology that leverages the virtualization to consolidate the heterogeneous network devices onto the industry standards, which performs high volume servers and also the switches and also the storages. And this NFV is compulsory to software defined network for providing the infrastructure how the SDN can run. So NFV and SDN are mutually beneficial to each other but not depend on each other. These two, NFV and SDN, are mutually going to be benefited, but these two are not dependent on each other, guys. This is what you have to keep in mind at the time of utilizing these SDNs and NFVs in your current designs. And how NFV look like? This NFV is having different things in it: virtualized network functions, NFV infrastructure, virtualization layer, computing thing, networking part, storage, and also NFV management and orchestration. These are the things which are presented in NFV. What are the key elements such as virtualized network function? It is a software which is implemented of network function with the capability of running over NFV infrastructure. What NFV infrastructure was, which includes for computing, for networking, and for storing resources that are virtualized standard communication APIs, which is an open flow, I can say it, guys. And how the things are for a conventional home network architecture, how the things are. This was the home network. We're having Wi-Fi phone, we're having IPTV, and this is the home gateway which is shown to you. These are the laptops and these are the smart lights. These are the doors and window sensors, and these are the single board computer which is Raspberry Pi, and this is a smart washer, and this is a smart refrigerator. All these things are connected to internet with the help of home gateway. It is connected to the public network where we are having different types of network circuits which are connected to cloud. This is how the things are shown to you in a conventional home network architecture. Got it, guys? And coming to NFV use case diagram, which shows you a conventional home automation system with a good representation of the things in detail, how IP version TV and virtualized home things are connected, which are shown to you in the previous rough diagram also, and what exactly the need of IoT system management was. The main need of IoT system management was we need to configure automatically. Automation is the system configuration which ensures you all the devices with same configuration and variations. If it is not controllable, the devices has to be maintained manually configurable, which are going to be avoided. And the second factor is monitoring operational and statistical data. Which kind of data is to be operated and which kind of statistical data has been utilized for taking a decision. These things are going to be monitored continuously in system management. And coming to improved reliability with the devices which are existed in the IoT system by extracting the data from those devices and whether the device is good and it is producing a good data or not. So it depends on the analysis part only. Your reliability factor is going to be improved. And coming to system-wide configurations, what kind of configuration is required? Either we require a security camera which is going to be good in morning time and it is not good in afternoon, evening time, it was not correct, right? So what kind of requirements are required for the user? So according to his requirements, system-wide configuration has to be picked and it has to be installed in IoT system. And coming to multiple system configurations, why multiple system configurations are required? Why? Because in home automations there are n number of different things which are existed. And also retrieving and reusing configurations. Retrieving and reusing configurations will plays a major role in the system management purposes. These are the things which are playing a major role in NFVs. And coming to how to manage a specific device, we are using SNMP. What this SNMP was? Simple network message protocol, where we are using an agent in managed devices to interact with MIBs. For suppose you are the client, you are sending some message, that message will be linked through the network and network managed station is going to encrypt it and it is going to send to a particular network with a managed device, where SNMP agent, simple network management protocol agent, is going to work on it and it is going to be stored in management information base. This is how managing a device by using simple network management protocol. And coming to the need of IoT system managements are, SNMP is a well-known and widely used network management protocol which is going to allow us for continuous monitoring and configuring the network devices such as routers, switches, servers, printers, etc. All these are managed by SNMP only. It was a widely used network management protocol. And coming to the SNMP components, which includes NMS, Network Management Station, first one, and Managed Device, and Management Information Base, and SNMP agent who runs on the device. These are the components which are existed in SNMP component. What are the different kinds of network operator requirements? Are network operator is having n number of requirements. Some are listed here for your better understanding. We generally prefer ease to use, easy of usage process, and also a proper distinction between the configuration and the data which is going to be generated. We need to fetch the configuration and state the data separately. And also we need to configure the network as whole, and we need to configure the transactions across the devices, and we need to configure these details in a good way. And also you need to dump and restore the configurations in a well mannered. And configuring data schemes and comparing configurations. Configuring data schemes is a different process and comparing configurations is a different process. Why? Because if you started comparing configurations, one IoT manager will configure in his own way, another IoT manager will configure in his own way. There are two different configurations which are done by two different IoT managers, and if you compare these two configurations, we are going to get a good one. And configuring the database schemas also, it will place a major role in this network operator requirements. And coming to role-based access control. In this role-based access control, what kind of role the device is playing in the network system, and what kind of access control links, for whom we need to provide access, for whom you need to provide security, all these things, consistency has to be maintained at the access control list. And also here we are using multiple configuration datasets which are configured, and we are going to support for both the data oriented as well as task oriented. Data oriented means on the we are depending on the data which is provided by the IoT devices. Based on data we are taking decisions, and the other one is based on the tasks we are going to access the control. This is how network operator requirements are presented. With this I will conclude my first part of discussing about IoT network and management. I will continue the same discussion in my next class with much more details. Thank you guys.
Like, share and subscribe. Hit the bell icon for more updates.